Okay, we are looking at 10.3. You should be watching this on Wednesday during e-learning. So this will fill in the 10.3 notes in your Chapter 10 note packet. We are still dealing with radicals. So Monday we talked about simplifying radicals. We talked about multiplying a little bit. Today we're going to do more operations with them. So we're going to add them, we're going to subtract them, we're going to multiply them. We talked about dividing them a little bit on Monday. But we're basically going to look at adding, subtracting, and multiplying. It's the same sort of idea. You've done this stuff before. You just kind of have to keep track of the radical and remember how to simplify it. So adding and subtracting radical expressions. First thing, make sure each radical is simplified like we did Monday. If there is a perfect square that can go into it, then you need to take it out front. Treat the radical as a variable. And what I mean by that is you are going to do the same sort of ideas. If you were adding 5x plus 7x, you do the same sort of thought process. So you want to think that the radical is kind of a variable because you're going to do the same thing we would as if we were adding 2x plus 7x. Okay? So we are going to add or subtract the number and keep the radical the same. So just like I said, if I had 2x plus 7x, okay, first of all they have to have the same variable, so they have to have the same, that's number 3. You can only add and subtract with the same number under the radical. They have to be common terms, so 2x plus 7x, they have the same x. Just like with radicals, it has to be square root of the same thing. Okay, if I add those, you add the numbers out front. 2 plus 7 is 9, and you keep the x the same. You do the same thing. If it's the radical of the same number underneath, you add or subtract the numbers out front, and then you keep the radical part the same. So let's look at A. If I look at A, I notice these are already simplified. You want to check to see if they're simplified first. So A, square root of 2, square root of 2, square root of 2, I cannot simplify. There's no perfect square that will go in there. Will multiply into that. So since they are all this radical, the square root of the same number underneath, you just add or subtract the numbers out front. So 3 minus 5 is negative 2. Negative 2 plus 4 is positive 2. So it's positive 2. You keep the radical part the same, square root of 2. It's as simple as that. So if they have the same number under the radical, you add or subtract the numbers out front, and you keep the square root part the same. So 3 minus 5 was negative 2. Negative 2 plus 4 was positive 2. And you keep the radical the same. 2 square root of 2. Now, if you need to pause this, if I ever go too fast, you can always pause this video and write them down and then come back to it. So as I look at this, the first thing you want to check for is to see if all the square roots are simplified. Square root of 3 I cannot simplify more. Square root of 5 I cannot simplify more. So I want to go through these. I can only combine them if they have the same number under the square root. So if I look at this is 15 square root of 3 minus 11 square root of 3. So I look at my square root of 3. You just subtract the numbers out front. 15 minus 11 is 4. You keep the radical the same. So 4 square root of 3. Now let's look at the square root of 5. Negative 14 plus 6. So negative 14 plus 6 is negative 8. You keep the square root part the same, square root of 5. I cannot combine those two because they do not have the same number under the radical. So that is my answer. Okay, let's look at some harder ones. So example 2. Okay, like I said, the first thing you want to look for is you want to check to make sure that both are simplified. Then you can look at trying to combine them. So as I look at A, example 2A, we need to make sure 54 is simplified. So what I mean by that is what is the biggest perfect square that can go into 54? So like we did Monday, you can start taking 54 and divide by perfect squares. The biggest perfect square that will go into it is 9. So I'm going to rewrite that as 9 times 6. Plus 2 square root of, same thing with 24. What is the biggest perfect square that goes into 24? And it is 4. So we're going to rewrite it as 4 times 6. So we are simplifying like we did Monday, finding the biggest perfect square that goes under the radical. Next thing we're going to do is we're going to look at it and actually take the square root. What is the square root of 9? The square root of 9 is 3. When I pull it out front, I multiply by the 4 that's already out there. And then I will have a square root of 6. I cannot take a perfect square out of the square root of 6. So that 6 is going to stay under the radical. So out of the 4, I brought the square root of 9, which is 3 out front. So I multiply that by the 4 that's already there. Square root of 6. Same thing with the next one. Plus 2. Square root of 4 is 2. So when I bring it out front, I'm going to multiply by the 2 that's already out there. And I can't do anything with the square root of 6. Let's say square root of 6. Now if I actually multiply those numbers, 12 square root of 6 plus 4 square root of 6, I can only add them if they have the same number under the radical. They do, so I just add the numbers out front. 12 plus 4, 16 square root of 6. So simplify, see which ones you can combine together. Okay, now let's look at the next one, B. So make sure everything is simplified first. If I look at 45, what is the biggest perfect square that goes into 45? That is going to be 9 times 5. Plus, biggest perfect square that goes into 20 is 4. So 4 times 5. And then 245, I don't necessarily know off the top of my head, so I'm using a calculator. Let's start taking 245 and divide by some perfect squares. It ends in a 5, so maybe 25. Nope, not going to come out even. 245 divided by, I'm trying to think off the top of my head, 9? Nope. 245 divided by 81? Nope. 245 divided by 36? Nope. 245 divided by let's see, I'll think on the top of my head. 245 divided by 121. Nope. 245 divided by 49. That was a tricky one. So 49 times 5. That was a hard one to figure out. So the biggest perfect square that goes into 245 is 49 times 5. Okay, let's go ahead and reduce this. So square root of 9 is 3. So if I take the square root of 9, that is 3. I'm going to multiply it by the 3 that's already out there. So that is 9 square root of 5. Plus square root of 4 is 2, so I bring it out front. 2 square root of 5. Square root of 49 is 7, so I bring it out front. 7 square root of 5. So simplify first, then go through and see if you can put any of them together. I look here and I notice that these are all square root of 5. Since they have the same number under the radical, I can add and subtract the numbers out front. 9 plus 2 is 11. 11 minus 7 is 4. So 4 square root of 5. Okay, let's look at C real quick. Let's look at for perfect square. So the biggest perfect square that goes into 24. So biggest perfect square that goes into 24 is going to be 4 times 6. So rewrite that as 4 times 6. Minus biggest perfect square that goes into 54, 9 times 6. Plus the biggest perfect square that goes into 96 is 16. So square root of 16 times 6. Let's go through and simplify. Square root of 4 is 2, so I bring it out front. So 2 square root of 6. Square root of 9 is 3. Bring it out front. So negative 3 square root of 6. And the square root of 16 is 4. So I bring it out front. 4 square root of 6. So simplify first. Then go through and you can only combine the ones if they have the same number under the radical. These are all square root of 6s, so we just add or subtract the numbers out front. 2 minus 3 is a negative 1. Negative 1 plus 4 is 3. So 3 square root of 6. Sometimes they will combine down to a single term. Sometimes they won't. You might get square root of something plus a square root of something, depending on if they can combine or not. Okay, let's look at D real quick. If I look at D, let's go ahead and look for the perfect square that goes into, biggest perfect square that goes into 27. That will be 9. So 9 times 3. Plus 8, biggest perfect square that goes into 12 is 4 times 3. And the biggest perfect square that goes into 75 is 25 times 3. So So simplify first before you try to combine them by looking for the biggest perfect square that goes in there. Okay, square root of 9. The square root of 9 is 3. If I bring it out front, I multiply by the 6 that's already there. So square root of 3 is 9. Square root of 9 is 3. 3 times 6 is 18. I still have a square root of 3 because I took the square root of 9 out front. So I still have a square root of 3. Plus, square root of 4 is 2. 2 times 8 is 16. So 16 square root of 3. Plus square root of 25 is 5. 5 times 2 is 10. So 10 square root of 3. And let's go ahead. These are all square root of 3, so I can just add the numbers out front. 18 plus 16 is 34. Plus 10 is 44. So 44 square root of 3. Okay, pause if you still need to write some of this down. Okay, next thing we're going to look at is we're going to multiply radical expressions. So we are going to look at multiplying radical expressions. We've already kind of talked about this. You can only multiply numbers in front of the radical. We talked about this some on Monday. So you can multiply the numbers in front of the radicals, multiply the numbers inside the radical. So this is kind of review. And then simplify the radical by looking for perfect squares, just like we've just been doing. You always want to simplify the radical by looking for perfect squares if you can. So multiply the numbers in front of the radical together, multiply the numbers inside the radical together, and then simplify the radical by looking for perfect squares, like we've been doing. Okay, let's look at A. If I look at A, I'm multiplying because there's parentheses. So multiply the numbers out front. 2 times 7 is 14. And then multiply the numbers under the radical. 6 times 3 is 18. And this will not give you full credit because you always need to simplify. So I multiplied the numbers on the outside. I multiplied the numbers on the inside. So now I need to simplify the square root by looking for perfect squares. So what is the biggest perfect square that goes into 18? 9 times 2. Simplify, the square root of 9 is 3, so if I bring a 3 out front, there's already a 14, so we're going to multiply the 14 by the 3. So square root of 9 is 3, 14 times 3 is 42. So 42 square root of 2. Okay, let's look at the next one. Multiply the first one, the numbers on the outside together. So 9 times 11, 99. I gave you the hint. Square root of 5 times the square root of 5. Square root of 25. And then what is the square root of 25? That is 5. So 99 times 5, which is going to be 495. Now you could have right off the bat, and I told you this Monday, anytime you're multiplying with the same number underneath, your answer is just that number. Or you could write it as the square root of 25 and then go from there. It doesn't really matter. Okay, if I look at C, I noticed I have a monomial times a binomial. I have one term out front times 2 terms inside here. So I'm going to have to think about distributing it. So we're going to take 3 square root of 2 times 4 square root of 3. Do not make this harder than it is. You're multiplying numbers out front, multiply the numbers inside, and simplify. So 3 times 4 is 12. Square root of 2 times 3 is 6. So 12 square root of 6. Now let's take the 3 square root of 2 and distribute it to the 6 square root of 2. 3 times 6 is 18. And then a square root of 2 times the square root of 2, since you're multiplying with the same number in there, it is just the number on the inside. So it is just 2. So 12 square root of 6 plus 36, 18 times 2. You cannot combine those because 36 does not have a square root of 6. You can only combine them if they have the same radical with it. So you cannot go any further. Okay, let's look at the next one. Let's try to distribute the next one. So as I look at distributing the next one, I have one term times 3 square root of 2 minus square root of 3, 2 terms. So if I start distributing, let's take 5 square root of 3 times 3 square root of 2. 5 times 3 is 15. Multiply the numbers on the outside. Multiply the numbers on the inside. 3 times 2, square root of 6. Now let's take the 5 square root of 3 and distribute it again. 5 square root of 3 times negative, if it helps to have a negative 1 there, that's fine. So 5 times negative 1 is negative 5. Square root of 3 times square root of 3, I'm multiplying with the same number under the radical. That is just 3. So 15 square root of 6 minus 15. You cannot combine those because the 15 does not have a square root of 6 with it. So that is my final answer. So we're distributing, but we're using the way we know how to multiply radicals with that. Okay, a couple more. Let's look at the next one. Example 4. Find the area of a rectangle in simplest form with a width of 4 square root of 6 minus 2 square root of 10 and a length of 5 square root of 3 plus 7 square root of 5. So as I look at this, I is looking for the area of a rectangle. So area formula for rectangle is length times width. We know that. So if I want to find the area of that rectangle, I give you the width, I give you the length, you are going to simply multiply them. So the length is 5, let me put the 5 first, square root of 3 plus 7 square root of 5. That they tell me, if you read that, that is my length. So it is length times the width, which is 4 square root of 6 minus 2 square root of 10. Now, as I look at this, like we talked Monday, this is a binomial times a binomial. 5 square root of 3 plus 7 square root of 5, 2 terms, times 4 square root of 6 minus 2 square root of 10, 2 terms. We're going to have to use the FOIL, which is a fancy type of distributing. So let's multiply my first 2. Now keep track of this. You guys can do this. When I multiply my first 2 together, you know how to multiply radicals. Multiply the numbers on the outside, multiply the numbers on the inside. 5 times 4, 20. Square root of 3 times 6, 18. So 20 square root of 18 when I multiply the first 2 together. 5 times the 4, 20. 3 times the 6 is inside the radical, radical 18. That's when I multiply the first 2 together. Now let's multiply my outside 2 together. So 5 square root of 3 times a negative 2 square root of 10. I know this looks complicated, but keep track of the 2 things that you're multiplying together. So as I multiply 5 square root of 3 times negative 2 square root of 10, multiply the numbers on the outside. 5 times negative 2, negative 10, square root of 3 times 10, 30. Now on the inside, if I look at the inside, 2, 7 square root of 5 times 4 square root of 6. Numbers on the outside. 7 times 4 is 28. And then multiply the numbers on the inside. 5 times 6 is 30. So 28 square root of 30. And then finally, the last ones, as I go through, we will have, grab another color. Okay, as I look at the last one, we have 7 square root of 5 times negative 2 square root of 10. 7 times negative 2 is negative 14. 5 times 10, square root of 50. Okay, let's go through and simplify and combine what I can. Okay, as I look at the first one, we have 20 square root of 18. Biggest perfect square that goes into 18 is 9. So we're going to write that as 9 times 2. If I look at my square roots of 30s, there's not really anything I can do to combine those or simplify those. There's no biggest perfect square that goes into 30. So we can just combine them the way they are. Since the middle 2 terms are both square root of 30, I can add the numbers up front. Negative 10 plus 28, positive 18, and keep it square root of 30. And then my last one, let's simplify the blue one. Negative 14 square root of 50. The biggest perfect square that can go into 50 is 25. So that is 25 times 2. Okay, let's go through and simplify. So square root of 9 is 3. So I bring the 3 out front, multiply that with the 20. So 60 square root of 2 plus 18 square root of 30. minus, if I bring out the square root of 25 is 5. 5 times 14 is 70. So minus 70 square root of 2. And then if I look at ones I can combine, the square roots of 2, they are the same underneath the radical. So I just subtract the numbers out front. 60 minus 70 is negative 10. Square root of 2 plus 18 square root of 30. And I cannot combine those because they do not have the same number under the radical. So that is my final answer. Okay, now we're going to go ahead and skip B real quick. So we're going to skip B, and I want you to find, okay, we're going to skip B, and instead of doing B, I want you to find the perimeter. So write this down, change this. Perimeter of example 4A. So instead of doing example 4B, I want you to find the perimeter of example 4A. They get, it's still a rectangle, okay, they give me the width and they give me the length. So I want you to think about, how do I find the perimeter of a rectangle? So the perimeter formula for rectangle is 2L, 2 times the length, plus 2 times the W. So as I go through and I look at my formula, it's 2 times my length, and if I look back up here at example 4, they tell me the length is 4 square root of 3 plus 7 square root of 5. So 2 times the length is 2 times 5 square root of 3 plus 7 square root of 5 plus 2 times the width. And as I go back up here and look at the width is 4 square root of 6 minus 2 square root of 10. So it's going to be 2 times 4 square root of 6 minus 2 square root of 10. Now if I look here, we don't have to FOIL because I just have a monomial out in front of the parentheses. So I'm just going to take my 2, that's my monomial, and I'm going to distribute it. So this 2 is technically outside the radical. Even though you don't see it, a radical, it's just no radical there. That 2 is still a number outside the radical. So when we multiply, we have to multiply it by the other numbers that are outside the radical. 2 times 5 is 10. So 10 square root of 3. 2 times 7 plus 14 square root of 5. And let's distribute my other 2. 2 times 4, so plus 8 square root of 6. And then 2 times negative 2, negative 4 square root of 10. So as I go through those radicals, are there any of them where I can write them as the perfect square times something? Square root of 3 I can't, square root of 5 I can't, square root of 6 I can't, square root of 10 I can't. So those are already simplified. I cannot combine any of those together because none of them have the same number under the radical. That is how you do a perimeter. 2L plus 2W. Okay, so here are the notes for 10.3. The rest of the time is yours to work on the homework. You can finish 10.2 homework if you need to. You're behind a day because you got it Monday, so you should have had plenty of time either in e-learning yesterday if you got Alex done or at home. But if you need to finish it, it's due tomorrow, and you need to come see me if you have questions. So the homework for 10.3 is going to be page 637, 1 through 13, 19 through 24, and 26. So that is the homework assignment for 637. This will be due Friday. We will go over a couple tomorrow, but you should have plenty of time the rest of e-learning to get a good start on this. If you have questions, you need to ask Mrs. Glassford, and I expect you to be working